In this video, we are going to cover the kinematic equations for constant acceleration. Kinematics is a subfield of classical mechanics and deals with the motion of point objects. We are not interested in the forces that act on the object, rather how that object moves. For example, a classic constant acceleration is that of freefall acceleration. If you drop an object from a cliff and ignore drag forces, the motion of the object can be worked out by following a point on the object, usually the center of mass, and applying the appropriate kinematic equations. If acceleration is constant, then the instantaneous acceleration and the average acceleration are equal. This allows us to work out the kinematic equations in two separate ways. This video will cover both ways side by side. We will start with acceleration. The average acceleration can be written as the final velocity minus the initial velocity divided by the final time minus the initial time. If we set the initial time to be equal to 0, then this equation becomes next. Next, multiplying both sides by time, and finally isolating for final velocity. The instantaneous acceleration can be written as a time derivative of velocity, which can be then rewritten like this. If we then integrate both sides, like this, and then we remember that a is constant, so we can pull it out of the integral. Grouping the constants together, if at t is equal to 0, the velocity is equal to some initial velocity, then the constant is equal to that initial velocity. And this equation can then be rewritten as before. The average velocity can be written if t naught is equal to 0, multiplying both sides by time, if we then say that the average velocity can be written as this, then we can also use an earlier result which said that the velocity is equal to the initial velocity plus an acceleration times time. Substituting that result into the average velocity. If we then put this result into the position function, this yields the kinematic equation for position. The instantaneous velocity can be written as a time derivative of position. Or, rewriting this equation, again taking the integral of both sides, this time, however, we cannot pull out v, as v is a function of time. So we substitute the equation for velocity. Grouping the constant together. Next, at t is equal to 0, the position is some initial position, this equation has the variable initial velocity. But suppose we don't know what initial velocity is. Instead, we could do this. The next equation to work out is this one. To derive this equation, I will use two other equations we've worked with so far. Rearranging this equation for time, so that I can then substitute it into this equation. Then I multiply both sides by 2a, and rearranging for the final velocity, we get the desired equation. And lastly, the average speed is equal to the total distance divided by the change in time. Okay, so we've worked out a whole bunch of equations. Let's summarize. Now, these 5 equations are for different situations. For example, the first equation does not have position. So this equation is an equation you would use when the problem does not have the position specified. The second equation, there's no variable for time. So this equation would be used if you do not know the time. The third equation is what you would use when you don't know the final velocity, but perhaps you know the other variables, like the initial velocity or the time. The third equation has a velocity, but it does not have your initial velocity. So if that variable is unknown, this is an equation you might use. And lastly, if you do not know the acceleration, you could use this equation. If the constant acceleration is free fall acceleration, we may write this equation but replace A with minus g, where g is 9.81 meters a second squared. Lastly, it's possible to be moving in not just the x coordinate, but in the y coordinate. So you could write of course, the V naught would be the relevant components, as well as the acceleration. Thank you for watching my video, and if you enjoyed it, feel free to give it a like and subscribe for more content.